What if the Earth had rings like Saturn? Were you aware that all 4 gas planets have asteroid rings? Yeah, although Saturn has the most vivid rings, the 4 gas giants also have rings. But why are only those planets ringed? Why don't rocky planets have? What would happen if the Earth has rings like Saturn's? Let's find out. Hello and welcome to Space Time. Subscribe to our channel and follow us. Why does Saturn have rings? Before we can question why the Earth lacks Saturn's gorgeous and colorful asteroid rings, we must first understand why Saturn does. Since the invention of the telescope in the 17th century, astronomers have been investigating and discovering the universe's deepest mysteries. Scientists have long been fascinated by Saturn and its famous ring of asteroids. Christian Huygens, a Dutch astronomer, was the first to detect Saturn's rings in 1655. Huygens was able to spot Saturn's main ring with a rudimentary telescope. However, it was unknown at the time that it was a ring and 2 enormous moons orbiting the planet were thought to be the cause. Only in 1850 did the British astronomer James Clerk Maxwell hypothesize that the rings were a collection of tiny particles orbiting the planet. However, the proper knowledge of how Saturn's asteroid ring evolved did not emerge until much later. In the 1960s, NASA and Soviet Union space missions began to investigate the solar system, notably the large planets. The Pioneer 11 spacecraft was the first to reach Saturn in 1979, and it captured exquisite photographs of the rings. These photographs revealed that Saturn's asteroid ring is made up of many small particles ranging from dust to house-sized pebbles. But how is this ring formed? Saturn's asteroid ring is a very intricate structure thought to have developed from an icy moon orbiting the planet. This moon, known as the parent moon, would have been destroyed by Saturn's gravity roughly 1 billion years ago, resulting in millions of tiny fragments orbiting the planet. The parent moon is thought to have been ice, comparable to Saturn's moons Enceladus and Mimas. These moons are primarily made up of water, ice, and rock, making them rather light. The parent moon would have been in an unstable orbit around Saturn due to gravitational interaction with the planet's other moons before being destroyed by Saturn's gravity. Finally, the resultant fragments were placed in a stable orbit around Saturn. Over time, these fragments collided and fragmented into smaller and smaller particles, resulting in the asteroid ring we see now. Scientists believe the majority of the ring is made up of water ice particles, while there are also small bits of rock and dust. Even though we now know how Saturn's asteroid ring evolved, many scientists continue to study it. For example, why do rings vary in thickness and density throughout different parts? Why do some rings have distinct features, such as the Cassini gap? The Cassini gap is a prominent feature of Saturn's asteroid ring. This gap is a comparatively vacant section in the ring that is thought to have formed due to the gravitational impact of Saturn's largest moon, Titan. Titan is thought to exert a significant gravitational force on the ring particles, pushing them out in a specific area and leaving a noticeable gap without rock or ice fragments. Invisible rings. The most vivid asteroid rings in the solar system are Saturn's. Jupiter, Uranus, and Neptune all have rings around them. Why can't they be seen with the naked eye? There are various reasons why it is impossible to see Jupiter, Uranus, and Neptune's asteroid rings from Earth. First, these planets' asteroid rings are significantly fainter and less dense than Saturn's. Second, the rings of these planets are closer to the planet, making them harder to identify from the planetary backdrop. Furthermore, most amateur and professional astronomers' telescopes are insufficiently powerful to differentiate these planets' asteroid rings from other celestial bodies. More powerful telescopes, including as the Hubble Space Telescope, have been used to investigate the planet's asteroid rings. But even with these equipment, the rings are difficult to observe and require careful picture processing to find. Another reason it is impossible to detect Jupiter, Uranus, and Neptune's asteroid rings from Earth is because their thick atmospheres distort light, making it much more difficult to see. The origin and composition of Jupiter, Uranus, and Neptune's rings, however, may be the most important reason why they are not visible from Earth. Saturn's rings are the result of the collapse of an icy moon which produced ice-rich rings, whereas the rings of the other 3 gas giants were formed by gravitational capture. Gravitational capture is the process by which a planet's gravity captures and anchors an object, causing it to become a moon or part of the planet's asteroid ring. This indicates that for billions of years, the three gas giants trapped asteroids and comets as they passed nearby, gradually building their rings. As a result, the rings of these three planets are not as dense and dazzling as Saturn's. Also, many of the asteroids that compose the rings of Jupiter, Uranus, and Neptune are black, making them much more difficult to view. It seems possible that if Earth had a ring like the three gas giants, it would be difficult to observe from Earth. Why doesn't Earth have rings? All that being said, the main reason the four rocky planets lack rings is due to their gravitational attraction. Because gas giants have a large mass, their gravitational power of attraction is great, and as a result, all asteroids, comets, and other bodies near them are trapped by gravity, and the rings grow gradually. However, because Mercury, Venus, Earth, and Mars have relatively low masses, they struggle to keep an asteroid ring. Another important thing to consider is the solar system snow line. The snow line is an imaginary line in the solar system that divides the regions where solid elements freeze and form water ice from those where they evaporate and remain gaseous. The snow line's location varies with distance from the Sun as well as local pressure and temperature. Still, it is usually found in the asteroid belt which separates Mars from Jupiter. The snow line is located in the inner solar system, around 5 astronomical units from the Sun. This implies that rocky planets, like his Earth, were formed from rocky and metallic components that did not freeze at this distance. Instead, these planets are primarily composed of silicates and metals. Water and other volatiles can freeze into ice in the outer solar system beyond the snow line, due to low temperature and pressure. This means that big planets like Jupiter, Saturn, Uranus, and Neptune have solid cores formed of ice and rock surrounded by atmospheres primarily composed of hydrogen, helium, and methane. Saturn's beautiful rings have survived to this day because they are located beyond the snow line. Because they are largely formed of ice, if they were the same distance away from Earth, they would have evaporated completely by now. This means that if Earth had an asteroid ring similar to Saturn's, it would evaporate soon due to its proximity to the Sun. Therefore, the joy of having rings would be short-lived. What if the Earth possessed rings consisting of rocks and dust, similar to those found on Jupiter, Uranus, or Neptune instead of Saturn's? As previously explained, the ring would be extremely dark and difficult to discern with the naked eye. To be visible enough, it would need a large number of asteroid fragments, which could only be achieved by destroying the Moon. Roche limit. Saturn's rings developed when one of its moons passed the Roche limit. However, what exactly is the Roche limit? The Roche limit is a critical distance that defines the smallest distance an object can approach another without being destroyed by gravitational tidal forces. This distance is critical for researching planetary systems and applies to natural satellites, planetary rings, and comets. In layman's terms, the Roche limit is an area surrounding a planet where the gravitational pull is so strong that any object that crosses it and does not have enough speed to escape on its own will be smashed to bits. This happened to the natural satellite that generated Saturn's rings. As it reached the Roche limit, it was unable to depart and was destroyed, resulting in the visible rings. In the case of the Earth, the Moon is quite far from the Roche limit. Also, we know that the Moon moves away from the Earth at a rate of 3 centimeters per year, ensuring that it will never approach close enough to form a ring of asteroids. But what if instead of the Moon, an asteroid exceeded Earth's Roche limit? Assume a massive asteroid, such as Apophis, approaches Earth in many years and surpasses the Roche limit, causing it to be annihilated by Earth's gravity, resulting in a ring of asteroids. What effects might something like this have on the Earth? An asteroid ring would provide a spectacular view from anywhere on the planet, particularly at night. But aside from the lovely views that would inspire many poets' verses, a ring of asteroids around the Earth would be inconvenient for humanity because it would impede numerous tasks that currently rely on a clear sky. One of them is astronomical observation. All astronomers across the world would be depressed because a ring of asteroids would reflect too much sunlight, obstructing the vision of all telescopes and observatories. However, all telecommunications and duties involving artificial satellites would be jeopardized because numerous artificial satellites would share space with the asteroid ring. Furthermore, an asteroid ring would jeopardize the future of space exploration by requiring spacecraft to perform complex maneuvers to avoid asteroids while attempting to escape Earth's gravity. Finally, the worst thing of having an asteroid ring is that Earth's gravity would pull in the majority of the asteroids, leading them to crash on the surface from time to time, resulting in a barrage of meteorites that would decimate all life on Earth. Without a question, while they are visually appealing and put on quite a show, our planet is far better off without an asteroid ring. But don't let this bring you down. Earth may not be able to have or require an asteroid ring, but what about an artificial ring around Earth created using human science and technology? That is considerably more plausible, because unlike an asteroid ring, a manufactured ring would benefit civilization. Would you like us to create a video depicting what would happen if the Earth had an artificial ring? Share your thoughts in the comments. Thanks for watching, and remember to like, share, and subscribe.